Hello dear students, so this is Dr. Vijaya Babu. So in continuation with the previous lectures of network analysis, so now we are in case 2 problem. So that is the problems whenever the combination of dependent and independent sources are given. So how to solve those type of problems, okay? So we'll try to go ahead now. Yeah, so this is the problem of combination of dependent and independent sources. Okay, I am considering it as case 2 because previously the previous videos we have done on case 1 where there were if there are two nodes are there, we might be getting two equations to solve it. Okay, two nodes, two equations, then it is sufficient. You can solve the nodal voltages, then you can achieve the targets, right? But here in this case, this is a combination of dependent and independent sources. Okay, so we'll try to observe. If we try to apply KCL at the nodes, we'll try to observe how many equations we are trying to get here. Okay, so before going ahead, so the question is being asked is the current I flowing through the top 4 ohm resistor, right? So that current you need to calculate now. Okay, so as I said earlier, whenever the question is given, immediately you try to redraw the circuit by removing the unknown parameters what is being asked and take that circuit in your control. Okay, so that is very important thing. So I'm going ahead now. So redrawing the circuit. So this is a 3 ampere source given. This is 2 ohms, it is 8 ohms, and it is 4 ohms, and it is once again 4 ohms. Okay, so now this is a dependent current source. The rhombus shape is a rhombus shape tells us it is a dependent source, and the arrow tells us it is a current source. So it is a dependent current source, and it is depending upon Ix. So that is why I can call it as current dependent current source. It is a current dependent current source, right? So now, so I have drawn the circuit once again by erasing the unknowns. So here unfortunately I have erased two things, the value of I and the value of Ix. So you should be able to erase only I because I is being asked. So you should not touch the value of Ix. Ix compulsory, you have to take it. Compulsory, you have to take it. It is mandatory. Okay, so because Ix is depending upon, or the dependent source current is depending upon Ix, then how can you remove that Ix? Then if you remove Ix, you will be in trouble. Okay, so the point is whatever the unknown being asked, only the value of I is the current that is being asked. So that current you can eliminate it. Is it clear? Right. Now going ahead, identifying the number of nodes. How many number of nodes there are? I'll try to show you with the blue color. Observe here quickly. This node, take it as A. Okay, similarly this node, take it as B, and this node, take it as C, and this node, take it as D. 4 nodes are there. Among them, you need to consider one as a reference node. So that is why I am calling it as VD is equal to 0 volts. It is a reference node, and A, B, C nodes are non-reference nodes. So let the nodal voltages as VA, VB, and VC. So VA, VB, and VC are being the nodal voltages at the nodes A, B, C. Okay. Now what is the next step in the procedure? You need to fix the branch currents. So first of all, I will try to fix the branch currents. So see here. So this current. Okay. So can I fix as I1? So it is not required because there is a current source in that branch. So take it advantage. Directly you take this current as 3 amperes. Whatever happens in the circuit, the branch, this particular branch current is strictly fixed to 3 amperes, right? So whatever happens in the circuit, outside of it, always this branch current is fixed and it is 3 amperes because there is a independent current source. It is not the dependent current source, it is the independent current source. So that is where the current coming out of is how much? It is 3 amperes. Okay, this branch is fixed. And coming to this 2 ohms, 2 ohms, already Ix is the branch current. Now, why to take headache by keeping one more current there? So it is not required, right? So try to keep that Ix as it is, and let us continue the problem with the same branch current, that as Ix. Now, taking here one more branch current, that is I1. Okay, now the branch at 4 ohms, take it as simply I2, and then the current through 8 ohms, take it as I3, and finally this current. Okay, so can I take it as I4? Not required, because you have the current source there. Take its advantage now. Okay, so that means you try to keep it as simply 2x. Okay, so you take that advantage of 2x. So that is why it is not required to take once again the value of I4. Okay, so keeping all this in mind, now I'll try to go ahead for the applying KCLs at the nodes. So applying KCL at node A. If you apply KCL at node A, entering currents is equal to leaving currents, right? So what is the current entering? That is 3 amperes is entering, is equal to 2 are leaving, it is Ix is leaving, okay, and then I1 is leaving. Now try to represent Ix in terms of nodal voltages. So how will you write Ix in terms of nodal voltages? So it is something VA minus VB divided by 2. Okay, this is Ix plus I1. So what is I1? VA minus VC divided by 4. Okay, so this equation we will try to multiply with 8. What will happen? 24 is equal to 4 VA minus 4 VB plus 2 VA minus 2 VC. So this is the best way, taking LCM and cross multiplication. So instead of doing that, directly multiply the entire equation with 8, because 8 is the LCM of 2 comma 4, right? Yeah, now going ahead, writing the final equation in terms of VA, VB, VC. So 4 VA minus 4 VB. Okay, so here you can take VA and VA, 4 VA, 2 VA, you can make it as 6 VA directly. 6 VA minus 4 VB minus 2 VC. Okay, so is equal to 24. Take it as equation 1. Okay, now I have applied the KCL at node A, and I got the equation in terms of nodal voltages VA, VB and VC. So however, one equation, 3 unknowns, we cannot solve the problem. We'll try to go ahead now. So applying KCL at node B. So that means Ix is the entering current is equal to I2 plus I3 are the leaving currents. Now what is the value of Ix now? So Ix is simply VA minus VB divided by 2 is equal to I2 is VB minus 0 by 4 plus I3 is VB minus VC divided by 8. Okay, now for this equation, so we'll try to multiply throughout with 8. Okay, so if you try to multiply throughout with 8, so what will happen? So now multiplying with 8 means, so 4 VA minus 4 VB is equal to 2 VB plus VB minus VC. Rearranging the things, so 4 VA, okay, 3 VB, so if you bring to the left side, so minus 7 VB and minus VC on the right side, you'll be getting left side plus VC equal to 0. So this is equation 2. Okay, now we have one more node, right? So that is at C. Apply the KCL. So applying the KCL, one current I1 is coming this way, right? So that means entering current is I1, then plus I3 entering is equal to 2 Ix. These are leaving. Okay, so I1 plus I3 equal to 2Ix. Now let me write the I1, I3 in terms of nodal voltages. So what is I1 now? I1 is VA minus VC divided by 4 plus I3. I3 is VB minus VC divided by 8. Okay, so is equal to what? 2ix. Now this equation, so you try to multiply with 8 throughout. If you try to multiply with 8, so 2 VA minus 2 VC, okay, plus VB minus VC, okay, is equal to multiplying with 8 na, then it is how much? 16ix. Now rewriting or rearranging this equation, so what will be getting? 2 VA, okay, plus VB minus 3 VC is equal to 16ix. This is equation 3. So this is equation 1, this is equation 2, this is equation 3. That means I have applied the KCLs at 3 different nodes, A, B, C. So I got 3 equations. I think my job is done. But unfortunately, okay, these 3 equations, if you clearly observe, all the 3 equations are in terms of VA, VB, VC and IX. That means 3 equations, how many unknowns? 4 unknowns. So it is not possible now to solve. If you solve 1, 2, 3, you will not be getting the solution, because to get the solution of 4 unknowns, you must have 4 equations. Okay, so that is why this problem will comes under case 2. That is the problems with combination of dependent and the independent sources. Okay, so whenever the combination of dependent and independent sources, if you apply the KCLs at the different nodes, then it is not possible to solve the problem, because there is one more independent parameter, that is the value of Ix. Okay, so you will be in trouble. That means now you need to investigate the last equation or the fourth equation. Compulsory you need to investigate the fourth equation to solve this problem. So how can we investigate the fourth equation? That means you can go with Ix. Okay, so finally the last equation is Ix is flowing through 2 ohms, right? That means the final equation, it is 2 ohms. This is VA and it is VB, and this current is what? Ix. So from this, okay, I can easily write the fourth equation as Ix is equal to what? So VA minus VB divided by 2. That means VA minus VB equal to 2Ix. This is the final investigated equation, that is equation 4. Okay, now tell me, how many unknowns are there? 4 unknowns are there, VA, VB, VC and Ix. How many equations are there? 4 equations. So upon solving 1, 2, 3 and 4, okay, so we will be getting the values of this VA, VB, VC. So the value of VA, so I can write it as 4.8 volts, and then the value of VB 2.4 volts, and the value of VC minus 2.4 volts, and the value of Ix is finally 1.2 amperes. Okay, so all the 4 unknowns, that is VA, VB, VC and Ix, are known for us. Okay, now I think I have solved the problem, but once again go back to the question. Finally now I have applied the what we call it as nodal analysis procedure, and I have find out all the nodal voltages VA, VB, VC and then the value of Ix. Okay, now go back to the question now. So what is the question? The question is being asked is what? The value of I. This I he is asking. So how will you calculate the value of I? So I, if you clearly observe, this is a 4 ohm resistor. This end voltage is VA and this end voltage is what? VC, and this is the current I that is being asked. Okay, so from this the value of I is simply is equal to, you can write it as VA minus VC divided by 4. Okay, so that means I is equal to, So VA minus VC, 4.8 minus of minus 2.4 na, plus 2.4 divided by 4. So upon solving this, so finally you'll be getting the value of current I as I is equal to 1.8 amperes. 1.8 amperes. Okay, so this is how you can apply the procedure on the network, then get back the nodal voltages. Once the nodal voltages are arrived, finally you go back to the question once again and check the unknowns, what is the unknown being asked, and then try to calculate that using the logics in the network, right? So this is how you can calculate the value of I. So whenever the problem is under case 2, that is a combination of dependent and the independent sources. Dependent and the independent sources. Okay, so thank you for giving this opportunity, dear students. If you really like the videos, just like them and subscribe them. Also, if you can comment it immediately, so that this will become encouragement for us to solve more and more videos, or we will be able to do lot of problems on networks. Okay, so thank you so much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.